ensures that the customer's testing and calibration needs are met. OneLab handles receiving, referral, transport, analysis, and delivery of results through an IT-based referral system for efficient laboratory transaction management. OneLab harmonizes and integrates laboratory test and calibration services, thus eliminating the need of the customers to shuttle from one laboratory to another to complete their laboratory testing and calibration requirements. With an extensive list of services, OneLab guarantees the accessibility and availability of consistent quality service, promises user-friendly instructions on testing and calibration requirements and pricing. So, how does it work? Customers through OneLab can have all of their laboratory testing and calibration needs in a single touchpoint. OneLab also allows customers to have an idea on the pricing for the desired tests and/or calibration. As soon as the customer hands in the samples to the nearest OneLab member laboratory, OneLab takes everything from there. The lab receives the samples and refers it to the laboratory that can provide the required service. OneLab gives its customers an access to track the status of their test requests through the customer portal, which will also be available in Android with the needed information being available at their fingertips. Customers just need to wait until the results are available, which can be received through email, fax, or pickup. Customers are assured of accurate and complete instructions regarding their testing requirements. How is this possible? With OneLab, customers from the industry, business sector, and the academe can have a more convenient laboratory testing and calibrations. No more expensive, tiresome, and time-consuming travel from one lab to another to complete testing needs. Through OneLab, customers are assured of high quality and efficient services through ISO IEC 17025 accredited internationally recognized member laboratories. OneLab is committed to providing timely, convenient, and readily accessible services to sustain high satisfaction rating from customers. One laboratory worldwide. This is OneLab.
Built upon the innovative design and unsurpassed quality of Omni's BeadRaptor family, the BeadRaptor 4 provides powerful performance in an extremely compact design. The BeadRaptor 4 is designed with a small footprint to maximize bench space. For ease of use, the BeadRaptor 4 has an integrated front-loading snap-in tube holder. Homogenize in volumes ranging from 500 microliters to 7 milliliters using the BeadRaptor 4. The powerful motor allows processing up to 5 meters per second and is ideal for soft tissue and cells. The BeadRuptor 4 is equipped with variable speed and time control to accommodate multiple sample types. The OmniTH tissue homogenizer is ideal for small-scale analytical laboratories. The TH features a powerful, compact 150-watt motor with variable speed control and separate on-off switch. The lightweight and ergonomic design make the TH a perfect fit for handheld operation. A specially designed stand clamp is also provided with the TH, enabling it to be post-mounted to a lab stand when applications require extended processing. A wide array of OmniGenerator probes are available. Choose from flat bottom for soft tissues and emulsions, or sawtooth configurations for tougher tissue samples. OmniGenerator probes feature quick connect couplings to ensure rapid probe exchange. The Omni PCR kit with disposable generator probes is ideal for PCR and extracting nucleic acids. OmniTip generator probes are disposable and completely eliminate the risk of cross-contamination. The Omni GLH 850 offers the ultimate performance with a powerful 850-watt motor and digital speed controls ranging from 5,000 to 25,000 RPM. It is capable of processing at smaller lab-scale quantities or at larger production-scale quantities up to 10 liters in volume. The GLH 850's robust processing ensures complete homogeneous and uniform particle size distributions. The integrated motor feedback holds set speeds during homogenization to ensure repeatable results regardless of any fluctuations in sample viscosity. The Omni GLH 850 features a timer that can be set from 1 second to 10 minutes and also features a delayed motor start time for applications requiring a fume hood during homogenization. The Omni GLH 850 is compatible with the widest range of generator probes from 5mm to 30mm in diameter. It is able to create fine emulsions by using the flat-bottom generator probes or process tougher samples by using the sawtooth generator probes.
Good morning. Welcome to our webinar for this morning on understanding the impact of bead beating in sample preparation of food for microbial analysis. Before we start our webinar, let us be reminded of the following webinar house rules. For those who are present here in the Zoom meeting room, please remain muted during the sessions unless requested to unmute. This is to help us focus on the active presentation shared on screen. Likewise, kindly turn off your camera as well. For all of our participants who are watching our webinar live through the DOST-ITDI Updates YouTube channel, your attendance for today will be checked. This is a requirement for all CPD events as mandated by the Professional Regulation Commission. To sign up for the attendance, kindly click the link provided in your email, in the email correspondence sent to you, or use your phone's camera to scan the QR code to be shown to sign up. Online form will be open by 10:30 a.m. and cutoff is at 5 o'clock this afternoon. So here are the options for you to accomplish the online attendance and evaluation form. You may visit the link for all of our audience from the YouTube channel. The link will be posted at the comment section of the YouTube channel. Only this link will be for the officially registered participants. The attendance form and evaluation form will open by 10:30 a.m. and closes at 5 o'clock this afternoon. You may also scan the QR code presented here using your mobile device so that when the form is already open, you can already record your attendance. Thank you. If you have questions for the speakers, please write them on the Google form provided in this sent email correspondence. We will also be posting in the YouTube channel comment section the link to the Google form for you to access and input your questions. Your questions will be relayed to the speaker during the Q&A portion. All unread and unanswered questions will be given to the speakers with your registered email address to be addressed at a later time. Always check your audio and internet connections to avoid any interruptions. If you will be disconnected, please rejoin by refreshing the DOST-ITDI YouTube channel. Registered participants are required to accomplish a webinar evaluation form in exchange of your e-certificate. The same form is utilized for the attendance. The deadline to answer this evaluation form is 5 o'clock today after the webinar. Links are sent to your registered email address. Please be reminded again that only one Google form for the attendance and evaluation. We would like to also announce that this webinar has been granted 2 CPT units for the following professions. First, for the registered chemists and chemical technicians. Second, for the registered medical technologists. And third, for the registered chemical engineers. So for these professions, you will get 2 CPD units by completing your attendance in this webinar. So it is important that you submit your attendance and evaluation by accessing our online attendance evaluation form. This webinar is being recorded for documentation purposes only and complies with the Republic Act 10173 or the Data Privacy Act of the Philippines. To celebrate this momentous event and to generate awareness, you are encouraged to take a selfie or a groupie while watching this webinar and post it on your social media accounts. Place it on the public setting with the hashtag OneLab Webinars. Who knows, you might be featured in our DOST OneLab Facebook page. So ladies and gentlemen, allow me to introduce myself. I am Admiral CW, a Senior Science Research Specialist from the Industrial Technology Development Institute and at the same time Project Coordinator of the DOST OneLab for the Research and Development Institutes. And I will be the MC for this morning's webinar. Good morning po sa ating lahat. Welcome to our participants here in Zoom and also to all of our participants who are watching live sa ating DOST-ITDI Updates YouTube channel. Once again, welcome po sa ating webinar brought to you by DOST OneLab and Omni International, a Perkin-Elmer company. This webinar is entitled Understanding the Impact of Bead Beating in Sample Preparation of Food for Microbial Analysis. So to start our webinar, we would like to request for your attention for the singing of the Philippine National Anthem to be followed by our opening prayer.
Lupang hindi Tutuyan ka ng magiting sa manlulupit. Di ka pa sisilid sa dagat at bundok, sa simoy at sa langit mong bagaw. May nilagang tula at awit sa paglaya minamahal. Ang kisap ng watawat mo'y tagumpay na nagdidingding. Ang bituin at araw ng kailan pa may di magdidilig. Lumalang araw na at ipagsinta, buhay ay langit sa piling mo. Sa piling mo, aming di kaya dapat ay mga apit ang mamatay ng dahil sa'yo.
Once again, good morning and welcome po sa ating webinar on understanding the impact of bead beating in sample preparation of food for microbial analysis. This is a webinar brought to you by DOST OneLab and Omni International, a Perkin-Elmer company. Once again, we would like to announce that this webinar has been granted 2 CPD units by the Professional Regulation Commission for our participants who are registered chemists, chemical technicians, medical technologists, and chemical engineers. And also we would like to welcome all of our participants who are watching live sa ating YouTube channel. Thank you so much for your attendance to this webinar. Now, what is the objective of our webinar? This webinar aims to provide the participants with the knowledge and skills required to perform DNA extraction from different samples. The webinar will present various techniques and recent technologies available for efficient extraction of nucleic acid from food samples. So that's what we are going to expect from this webinar. And to give us an opening remarks and to welcome you all for your participation para po sa ating webinar for today, let us all welcome the project leader of DOST OneLab, at the same time the Chief Admin Officer of the DOST Regional Office number 9 at Zamboanga Peninsula. Ladies and gentlemen, let's all welcome Ma'am Rosemary Salazar. Ma'am Rose, good morning.
Hello, good morning everyone. Yung buntag sa atong tanan because I'm now already based in Pagadian City where the major dialect is Bisaya. To all our member laboratories of the DOST OneLab Network, resource speaker from Omni International, organizers from DOST FNRI and ITDI, our dear participants, good morning to all of us. Maayong buntag sa atong tanan, and buenos dias a todos. First off, I do hope that everyone is safe from the tropical depression that we experienced in the last few days. And I welcome all of you to this webinar. As mentioned earlier, this is organized in partnership with Omni International, a Perkin-Elmer company. We are truly grateful of this partnership, which will help our member laboratories and laboratory personnel to enhance their knowledge on microbiological analysis, especially now that our economies are improving preventive mechanisms to prevent future pandemics. So bead beating, particularly food samples, may on the surface look very basic, but the complexities of what and how to bead interacts with their samples is driven by the goals of downstream processing, which our esteemed resource speaker will tell us this morning. So without much ado, I welcome everyone again, and I know that we will all be learning a very important topic today. So enjoy everyone. Buenos dias a todos. Thank you, Admer.
Thank you so much, Ma'am Rose. So yun po, na-welcome na po tayo ng ating OneLab project leader, Ma'am Rose Salazar. At this juncture, let us get to know who will be our speaker to give us this topic for this morning's webinar. Let me call on Ma'am Christine Eden Sevilla, OneLab project staff and science research specialist too from DOST Food and Nutrition Research Institute. Ma'am Christine, good morning.
Good morning po. Good morning to all our participants, to our OneLab members, and a pleasant evening as well to our speaker and our partners at Omni International, a Perkin-Elmer company. So today, I am honored to introduce our speaker. He was a former microbiologist for iCubate, where he performed method validation of an FDA-approved medical device. He then became an application scientist for Omni International, where he was responsible for integrating sample preparation equipment with a wide variety of downstream analysis, which this includes qPCR, HPLC, reverse transcriptase qPCR, ELISA, DNA sequencing, and mass spectrometry. With a Bachelor's of Science in Microbiology from the Auburn University and a Master's on Cell and Molecular Biology from the Georgia State University, he is currently an application scientist for PerkinElmer Applied Genomics. He has also co-authored several publications and a patent, which includes the validation of a direct-to-PCR COVID-19 detection protocol using mechanical homogenization. Ladies and gentlemen, let us all welcome Mr. Caleb Proctor on his talk, Understanding the Impact of Bead Beating in Sample Preparation of Food for Microbial Analysis. Sir Caleb.
Good morning or good afternoon to everyone, depending on where you are in the world today. Today I'd like to talk to you about the benefits and various effects bead beating has on your samples and how understanding these effects can help you tailor make your assays and SOPs to maximize results downstream. Let's dive in. So what is bead beating? For those of you who've never dealt with homogenizers or others that have, but not necessarily a bead mill, bead beaters are a type of homogenizer. These instruments deliver high shear inside of a tube using various types of beads and tubes to accommodate an enormous assortment of varied sample types. I always like to shorten our universe of samples into a quick saying. We can process everything from bones to bacteria. Unlike other homogenizers that you may have had experience with, a bead mill is uniquely equipped to handle the needs of sample prep compared to other methods that often find a way into microbial molecular testing. Homogenizer devices like blenders, sonicators, rotators, and others do not offer the same protection to the sample like a bead mill does. Bead mills are designed with the researcher in mind. All of the previously mentioned devices struggle to prevent cross-contamination and carryover between samples, as well as struggle to handle the throughput needed in modern laboratories. Some require disassembly or rigorous cleaning or sterilization just to add a follow-up to samples in a queue of a sensitive assay that demands sample-to-sample cleanliness. Bead mills put each individual sample in a tube that isolates the sample from contamination of handling, processing, and storage. This type of device is ideal for analytical microbial testing. When I'm asked about which beads to pick from the plethora of samples that we are tasked with processing, I start by identifying the exact sample and the goal of the downstream. Typically, it's very important to match the beads with this physical sample you're working with. A good rule of thumb is large samples require large beads. When looking at food products, we at Omni classify most of them as hard tissues. That includes muscle, fruit, vegetables, and even finished products like edibles. Each one of these need the high energy and high force of heavy ceramic beads that can shred the sample and its cellular components into a homogeneous solution, where you as a bench scientist can then proceed to extract the analytes out of solution or suspension for detection downstream. Here in this slide, you can see that our recommendations for beads to use are abundant and change with the matrices of the samples as they get tougher and denser in nature. These type of bead recommendations work well when a technician is working with solid samples that need to have cellular analytes from tissue analyzed, or if you're looking for something like DNA, RNA, protein, or even elemental analysis out of a sample. These recommendations are always a great starting point. However, all of those recommendations go out the window when you are working with a microbial sample. Microbes carry their own special set of rules when analyzing their presence in food or other samples you process in your lab, like soil, environmental, or fecal samples. To begin, we should evaluate the effects of the beads on the nascent or invasive microbes using methods that I would recommend from this chart. If you were wanting to look at food samples for some sort of non-microbial analyte, DNA, RNA, proteins, small molecules, etc. from just a tissue, this is the effect that would likely present itself with regards to the viability of microbes in those food samples. Here you can see some of our data featuring food products like cabbage, spinach, and lettuce. These are all very common samples and some that you may have some experience with. This data is from an application note where we show green fluorescent protein tagged E. coli spiked into samples that were homogenized and then subsequently plated for quantity evaluation. These colony counts are showing the effectiveness of the recovery of the spiked E. coli from the sample after both the bacteria and the sample have been subjected to homogenization inside of a bead tube. From these photos, you can clearly see that the spinach, tomatoes, and lettuce have all been liquefied. Each of these samples can easily be pipetted and would qualify in many people's books as homogeneous samples. And to be honest with you, for most people's needs in our industry, this might be totally fine. These sample preparations would resemble many manual disassociation methods of tissue commonly used on your bench tops today. However, you can see from the colony counts that each of these matrices are producing countable colonies. And the only way to get countable colonies is if these organisms survive. On each of these colony count plates, we dilute the spiked sample to the same concentration as the control. And each time nearly zero lysis was observed as measured by the cells that were able to replicate and produce colonies. At this moment, if you feel like everything you know about homogenization has been turned on its head, you will not be alone. There are many factors at play inside of a processing tube, which result in the effects we see on these organisms surviving the incredibly violent and effective means of sample dissociation. Everything from size, concentration, and species of these microorganisms can come into play with how they avoid lysis and can continue to survive post-homogenization. Some of these microbes are easy to lyse. Others resist both chemical and physical lysis to a point where methods must be tailor-made to fit the needs of the process or downstream assay. So how does this impact your testing? In scenarios where you would like to keep your target organism alive, the correct path to take would be to use larger beads that would disrupt your sample and not destroy the organisms which are inherent in and on the matrix. This is relevant to the recovery studies seen in meat and produce or any product that still uses culture methods as a base for initial detection of microorganisms. You can see from the picture above that the produce samples that we have processed are going to fit easily into the sample processing that currently requires a blender. And you have the added security of knowing that the microbes are still intact and alive, ready for plating and further downstream detection. This effect is not limited to produce as seen on the slide. It is inherent in all processing of all types of other esoteric samples that we will discuss later. The thing to remember from this slide is the larger the beads, the less effect on the microbes present in the produce or any other sample you work with. The matrix you are working with may fully disintegrate, but the microbes inside and on the solution are still intact. This may be confusing to think about, but there is a strange dichotomy at play. The large beads do destroy even the toughest samples presented to them, like those tomatoes or mussel. However, before this is all over with, it's my goal to make sure you understand the impact of all our bead media. On this slide, you will see the complete opposite of what you just observed. Here are the effects of completely destroying the microorganisms. Those colony counts you saw from the last slide have now been inverted and instead are quantified by the lack of colonies to count. How do we accomplish this? It might sound counterintuitive, but we use smaller beads to lyse the small microbes. All of these figures are from a poster we presented at ASM Microbe a few years ago. The graph you are looking at currently shows the effects of beads during homogenization on bacteria from purified cultures. Just like in the last slide, we plate down all of these target organisms on growth media and incubate them overnight to evaluate how many of these cells are still intact and are capable of replication. We quantified percent lysis by reduction of living cells on the colony count plates as compared to non-homogenized controls. If you'll look particularly at the x-axis of each of these graphs, you'll see the same trend present itself across each of these organisms. As the bead media diameter gets smaller, the lysis of the bacteria gets more efficient over the same amount of time. This effect is seen across the tested species of bacteria and even across kingdoms in tested yeast species, although the data is not presented here. The yeast species are the easiest organisms to lyse, very similar to eukaryotic cells that we saw in the previous slide, like the plant, tomato, spinach, cabbage, and muscle tissues. In our experimentation, we control for the number of beads that were in each tube. With the smallest beads, the 0.1 millimeter beads, control of those numbers is only possible by using density as our starting point and carefully controlling for the weight to match that density. It may shock you to know that ceramic beads are much denser than glass beads. The difference between the weights of ceramic and glass is over 2x different. However, we can see that the weight of the beads matters much less when looking at the effect on lysis. Looking at the E. coli graph, this is very clear. The heavy ceramic beads perform better than the glass beads when looking at the 0.1 millimeter beads, but when looking across all the sizes of bead media, there is never an occasion where the larger 0.5 millimeter diameter beads outperform the smaller bead diameters. These lysis numbers are additionally validated by the yield of analytes purified downstream. In Table 1, you see the bead beating yields increase along with bead beating times, verifying that the bacteria are being popped open and the genetic contents being released into solution for extraction. How does this all make sense, you might ask? The reason why these small beads are more efficient than their larger counterparts against microbes is not fully understood. We know that it's not an effect driven by the beads hitting the microbes, because even the largest beads mix and move the solution enough to contact all the cells in the sample in order to homogenize a solution. And we saw the effects of the large beads on the last slide. There's little to no destruction of spiked organisms, yet the sample itself is very much liquefied. What I like to point to as a possible explanation is the bead number in a tube. On an equal weight basis of ceramic beads, the 0.5 millimeter beads for both glass and ceramic have an average count of 4,000 beads in the sample tube, and the 0.1 millimeter beads are present in the hundreds of thousands, easily 50x fold increase. It's crazy the difference in number of beads that you can have by changing the radius of the sphere. We think it's more about the number of beads in the solution and their effect on the microbes because of how liquids perform under pressure. As the bead moves through the liquid, its displacement causes disruption to each of the cells in the cavitation behind the quickly moving object through that liquid. But it is just pure speculation. We do not know the effect that these small beads have, but what we do know is that the effect is both measurable in analytes and colony counts downstream in purifications and plating methods. In the right applications, use of the smaller bead media provides a superior method of lysis when compared to even chemical treatments. This method can be completed in minutes compared to tens of hours of incubation with enzymes to get the same effect. All of this information is important. However, does this data of cultured microorganisms apply to food testing? One immediate way that it is useful is an added way to lyse bacteria from cultured pathogens. Beyond the typical proteinase K or lysozyme digestions, this can be an added benefit inside labs. We use PBS as a nice, inexpensive, non-toxic buffer for a processing buffer in conjunction in our bead mills to lyse cultures in our lab that can be immediately subjected to purification. This is because the exposed DNA, RNA, or proteins are available within minutes of processing the raw sample on benchtop. It can be a great aid in a high throughput environment where samples are piling up and tasks need to be quickly completed. However, beyond cultured microorganisms, there are countless other organisms that cannot be cultured or take too long to culture. It's with these organisms that the bead mill can help make new workflows or assays that may not be self-evident currently. The beads work well in lysing organisms that are already in suspension and can maximize the recovery and the lysis of intracellular analytes in methods that are not already getting full lysis through heat, chemical, or enzymatic treatments. This slide is all about the combined efforts of both the large beads that can get both the homogenization of the sample and the small beads that can ensure maximum lysis of microbial communities which are either residing in or contaminating the foods you're working with. The synergy of the combined beads cannot be overlooked. Where the smallest beads are great at lysing microorganisms, they fail at grinding up tissues. Using the small beads as a lysis matrix alone is near the equivalent to putting your sample in a sandstorm. The beads just abrade the tissue, and the sample never really is fully processed. And you eventually will boil the buffers that you're using to process the sample before most of the sample is homogenized. However, the large beads excel at destroying tough tissues and putting samples into solution. By combining these effects, we can see the powerful result in downstream analysis. Here in the slide, the data shown is not from the most pleasant samples. These extracts came from mouse bowels, but the picture I want to paint for you is most easily shown with this data. So bear with me. In this table, pay attention to the highlighted cells on the right. Those are total nucleic acid extractions, which resulted in high quality, high quantity DNA. I do not want to go into the specifics since this is not a DNA specific talk, but look at the yields. The first number you see is the total DNA extracted with a combined fill, and the second highlighted number was an extract using the exact same sample, but only using the larger bead media to facilitate lysis. The difference between the two is quite significant. The big takeaway here is that using the combined efforts of the large and small bead media will give you a real look at the microbiome with the power of mechanical lysis. Whether it's DNA, RNA, or proteins, the microbes present as contaminants or oral flora contain intracellular analytes that need to be exposed. In this particular case, because of all the microbes present, the result of the combined lysis provided by the small beads and the large beads were an order of magnitude higher than the large beads alone. As I said previously, the small beads would have no effect on the tissue. It's only through the combination of these bead media that we get this spectacular result. These effects are not limited to mouse bowels. The microbe-rich bowel just gives a great look at the effect that I'm talking about. In food in particular, there are molecular assays that may benefit from this type of sample preparation technique. Our preparation method allows for a consistent starting point for your analyte detection with almost all the cells present fully lysed. The effect compounds downstream. For your assays that are working already with incredibly small quantities of organisms, we can ensure that a maximal amount of target analytes are put into suspension. This is particularly beneficial for analytes that are intracellular. In other industries like vector surveillance and ticks, our method allows for a decrease in CT values, which drive down the limits of detection so that researchers can consistently detect pathogens at quantities that are on the lowest limit, since we are ensuring all of the pathogenic material that is in solution is coming out of those cells. These same techniques can improve the limits of detection in assays that you may currently be using that require molecular testing. The methods would only need to be validated by your lab once, and the speed and sensitivity of mechanical lysis could be realized. Additionally, with this type of sample preparation at the beginning, new assays for detection of not only microbes but other analytes can be created. Having an increased return on the amount of analytes of any type in an extraction method could allow for an assays to be developed that eliminate culture or enrichment from the beginning. Those steps add cost and time to assays that are already cost and time sensitive. Additionally, these types of methods allow for automation to be established in the laboratory. While this method isn't automated in its own right, the tubes themselves work well with automation and don't require special care with the sample preparation by experienced technicians who each have their own individual bias when using manual disassociation techniques. The machine itself delivers the exact same results every time it's activated. I hope that in this talk you were all able to discern the benefits of bead beating on microorganisms that may be present in food. The major takeaways that I would like to leave you all with is the devil is in the details, and that these details are: do I need my organism alive in the sample, or do I want the sample and the organisms completely disassociated. If the answer is keeping all the organisms alive, then you as an operator should be keeping the beads as large as you can and the energy imparted into the sample as low as possible. This will give you the best recovery possible of any organism you are looking to culture out of a sample. If you want the best method for recovery of intracellular analytes from target microorganisms, you must introduce smaller beads into the mix to ensure the microbial cells are fully lysed and their contents released into solution. I hope this information helps you all further develop exciting assays that need bleeding edge limits of detection lowered, or at the very least streamline the workflows in your laboratory that utilize more microbe-friendly sample preparation than open, non-sterile vessels or single-use blenders. At this time, I will now take any questions you might have from the chat or from the audience. I appreciate all of you taking the time out of your morning or evening to come listen to me talk about our research using bead mill homogenizers. If you find yourself coming up with any additional questions later on, feel free to reach out to me or my team. We will gladly help you pick the instrument for your sample preparation.
Okay. Thank you so much, Sir Caleb, for that presentation about the understanding the impact of bead beating in sample preparation of food for microbial analysis. Before we proceed to our Q&A session, I would like to call someone from Omni International for us to have our short competition, short contest sponsored by Omni International. Ma'am Juntan, are you already present here? Okay, let me make you a co-host. Okay. Okay. Please unmute.
Hi, good morning, Sir Chris.
Yes,
Hi,
please
can you hear me?
proceed. Yeah.
Yeah. Okay, so I think you might need to unmute Caleb as well because he will be hosting this this mini quiz that we have set up. So while we wait for Caleb, I would like to invite all the audience here to use your mobile phone to scan on the QR code to join us in this quiz. We will be giving away 3 prizes to the top 3 winners. There will only be 3 questions, so either scan the QR code to join or go to menti.com and you can enter the code 92611954. Okay? Great, I can see someone has joined. More have joined. Hey, Caleb.
Hey, June, how you doing?
Good, thanks. Good to hear you. Okay,
Thank
so
you.
I'll pass the time to Caleb.
Awesome. Well, I'd like to thank the FNRI organization for giving me the opportunity to speak tonight. It was really awesome to be introduced like that from everyone and to have the time to speak to everyone. So I really do appreciate it, and it means the world to me.
Okay, so I guess we have already 27 joining our,
Yes.
more than 30 joining already our
Nice.
short contest.
Okay,
So
Good
again,
luck.
you can go to the www.menti.com and enter the code 92611954.
Good. I try to make some of these questions a little difficult. Make sure it's not too easy of a contest. We don't want like a 6-way tie for first now, do we?
Okay, you can still continue to join, and then for those who have joined, you can fill in your details so that if you are the winner, we can send you a prize. So the code is still at the top of the screen. If you missed it, you can still go to menti.com and join with the code 92611954. Okay, we will need your details to send you the prize if you are the winner. Sir Edmer, how many people should we have before we start, do you think?
I think we can already start. I guess maybe some are still joining, but I think 50 is already enough.
Okay, great.
Yeah, okay.
Okay, so we can start the countdown very soon. So get ready on your devices, and then I'll pass this time to Caleb again.
Awesome. Oh, so yeah, so I guess these are the questions. So what bead media would you select if you were trying to lyse bacteria found in and on the samples? And this would be, the goal would be to get all of those intracellular analytes out here. That was fast. No, these are wicked fast questions.
Yeah.
Or I'll read the next one faster. That'll be.
Whoa. So this the leaderboard. We have some winners.
Nice.
Nice. So Elsa is on a roll. Next question coming up.
All right. What are the benefits of lysis of samples with mixed bead media? Is it A, maximum output of target analytes, B, complete disassociation of samples, C, more reproducible results, or D, all of the above? That's awesome. Good, at least if people are paying attention here. I like that. That are really good guesses.
Woohoo, Pinky.
Pinky's killing it.
We have a new lead.
Yeah. Okay, the last question. You can make it or break it.
Homogenization is like centrifugation. True or false question? Nice. That was good. That was really, it's like a classic grad school test question. Just this is the make or break it move.
Oh, very close. We have a winner.
Nice. So, good job. Congratulations.
Yay. Okay, so our team will contact you if you are the top 3 here. Thanks for this time, Sir Edmer, and then pass the time back to Sir Edmer for the Q&A.
Thank you. Thank you so much, Ma'am Juntan. So that is the very short. And congratulations to our winner, Ma'am Sol. So whoever Ma'am Sol is, so thank you so much for joining the very small contest. But definitely we have seen that you have learned something from the talk of Sir Caleb Proctor. Okay, now let us proceed to our Q&A session for this webinar. Again, for our participants, a link to our Google form wherein you can key in your questions is posted at the comment section of our YouTube channel. So let me throw the first questions to our speaker. The first question is, this is asked anonymously. In cases wherein beads are not available, Is it okay to homogenize the sample using the bead raptor equipment without the beads inside the centrifuge tube? Would it affect homogeneity of the sample in a huge way? Thank you.
Yes, absolutely. It will affect it in a huge way. Typically, nothing will get done, right? The beads are the part of the bead mill that do the work. So you can, with enough force, shake that tube with the bead beater until the sample disaggregates. It's going to have very little effect on the microbe. And it's going to take a long, long time to actually get that process done. So I wouldn't recommend it. It's not optimal at all. It can be done in some very soft tissues, but for the vast majority of samples, you're really going to need some beads to actually break those samples up and get those analytes out.
Okay.
I hope that
Thank you
answers the question.
Yeah, you did. Thank you so much for that. The next question is still anonymous. Is it okay to use different types of beads in one tube or per run? Example, is it for example, in glass or in a ceramic one tube? Thank you.
Yeah, so that was kind of the crux of this talk, right? Was to show the benefits of using both, right? In some scenarios, you do want to use both. If you really want to try to get lysis of all the organisms present in the sample, you want to hit everything from bacteria to the actual eukaryotic cell lines you have there. You want to use a mixed speed media, because using just the large media alone, you're only going to have lysis of the matrix, right? So the sample, like the muscle or the plant tissue you're working with. And if you only are using small beads, you actually won't lyse the sample that's there, right? So it'll look like in your tube that you still have a whole piece of what you started with. And at the end of the day, you're lysing all the microbes that are on top of that sample, but you're not getting anything inside of the sample. So using mixed beads is absolutely, it's quite optimal. In fact, I will say, instead of using glass, I would totally use ceramic. We have way better results with that. I would be happy to send you the data on that end. Ceramic beads just give you better results pound for pound every time, and they're cleaner.
Thank you for that. Next is still anonymous. Which sample is more difficult to lyse? Is it vegetable food matrix or a chicken food matrix? What would be your recommended type of bead to use for lysis? Thank you.
I feel like that's kind of a trick question, right? Some vegetables are going to have seeds, and seeds are incredibly tough to lyse. But for the most part, the graph would go, soft tissue would start down here with, like brain and very just easy to, you could crumble these samples up in your hands yourselves. I would say leaves and stems are kind of on the upper end of that, roots as well. But yeah, I would definitely qualify tougher to lyse samples to be, muscle and some of these plant matrices for sure.
Okay, thank you so much for that. Next question actually is, she would like to be declared. This is a question from Ms. Rainelin. Could you help the young entrepreneurs? I guess the question from our participant is about a certain research study which they use for entrepreneurship. Then does Omni International has that kind of service wherein you assist some entrepreneurs?
Oh, entrepreneurs. Okay.
Yeah.
That's the word. Okay. As far as young entrepreneurs go, Omni started off as a very small company. And I definitely, my background came from startups and things like that. As far as young scientists go, it's really, it's very, gosh, I don't know how to say it. You really want to get out there and just work, and you want to find something that's important that touches a lot of lives, and you want to find a way to make it work. It's a very, very broad scoping question. I don't know how to really answer that quite well. I'm definitely not the perfect source of information for this, but for the young folks out there, I would want to find something and make sure it's unique. I harp on this for our new products is that how are we going to be different? How are we going to have something that is both good for the market that we're trying to address, but at the same time, how is it different than the competition? How is it going to compare? Because at the end of the day, when you're going up against, the large organizations out there, you're going to need very different products that support, common needs that affect a lot of people. So that's kind of I know it's a very broad answer for a very broad question, but I definitely think you need to be different and you need to work very hard to get it done. And that's, it's the long and short of it.
Thank you. Thank you for that. The next question is, I guess our participant is just curious, and this is given as anonymous. Because of the COVID-19, is this technology about bead beating, was this actually being applied to samples which were tested and related to COVID-19 detection or any researches?
We did apply, and this particular ones that I showed here were not COVID-19, but we have used our bead. The beauty of our bead beaters is that they can be used in almost any sample, right? Where we had, going back to being unique, where we had the biggest effect on COVID was on saliva testing. So the bead beaters we were able to use to the bead beating tube itself to collect saliva. And then we were able to bead saliva, which one reduced the viscosity of the saliva. So the saliva would be too viscous to actually pipette. We would reduce the viscosity by bead beating it. And that's actually was published by one of our customers, made a huge publication on that, along with the increases in CT values that you saw. So you not only did you have a method that was able to be actually fabricated because of the homogenizing process existing, but it actually increased sensitivity to help detect COVID better than the current method. It was a very synergistic product. I would say, at the end of the day, our homogenizers didn't have a huge impact with COVID-19, but it definitely helped in a handful of universities around here in Georgia, where we're based at, where they deployed the saliva testing kits.
Thank you for that. The next question is actually just a clarification. Maybe some of our participants are actually not more into the hardcore science, but just interested to join our webinar. Just can you actually explain to them what's the purpose of having lysis of our cellular when it comes to microbes?
Okay, so with any molecular testing, you have an analyte that you have to detect. These analytes often are found intracellularly. So let's say you were looking for E. coli in lettuce, kind of like what we were talking about earlier. Some of the typical assays would be you would plate this E. coli out, you would grow it overnight, and you would be able to detect it from that culture. Other methods could exist and do exist where you could lyse that cell, and inside that cell is DNA, and that DNA can be extracted, purified, and at the end of the day, you can have specific primers to amplify only the E. coli DNA. So you've got all the DNA there, right? You've got DNA from the lettuce, you got DNA from you because you were handling the sample poorly, you got DNA from your dog because your dog's in the room with you, and you got E. coli DNA, but the primers will specifically amplify that DNA from the E. coli. And you can say with great certainty that there is something there. And there's even quantitative methods that you can say there's a lot of something there, right? So you can build methods around having good, I would say, QC practices in laboratories that are sampling food, or even in the case of COVID, where you're doing detection and monitoring of the population, things like wastewater. You can use our methods to lyse open these cells or these particles in the case of a virus to get those intracellular analytes out. And the beauty of a lot of these analytes is that they're water soluble, so you get them into water and you can transfer them downstream and yada, yada, yada. But as it goes, that's why you need to have full lysis, because without full lysis, you do not get all of those cells out. And when you're working with E. coli, or you're working with other contaminants, the number of cells are so small that you need 100% license. Like getting half of 150, right? So if you had, wouldn't you rather have $50 or $100, right? The answer is always going to be $100, right? You're going to want all of the money, or you're going to want everything possible that you can get there. So that's where the benefit of the method comes into play at it. I hope that kind of explains. It's me rambling about cellular license. So
thank you. And it actually contributes to our efforts when it comes to ensuring food safety in our community. Okay, the next question is also given as anonymous. The questions, actually there are, let me just check, 2 questions from here, or 3 questions rather. What's with the combined bead system that made it yield high recovery of the target microbes or microbial genetic material? That's the first question. The second one is that, what is the amount of sample needed for this bead extraction? And the last one is, does this system support or needs pre-enrichment of the sample? Just let me know if I need to repeat one of those questions.
I try to formulate my answers. I try to formulate them real fast. So the first question was about, gosh, now I missed the first question. I'm going to miss all of them now.
Let me repeat the first question first.
Yeah, go back first.
What's with the combined bead system that made it yield high recovery of the target microbes or microbial genetic material?
So the reason that the combined lysis gives you the best effect is that the cells, the target cells in this scenario, so going back to the slides, that was a gut microbiome, right? So in the gut, you've got if you remember back to like basic biology, right? You have your folds inside of your small intestine. And inside of there, on top, you've got a layer. And in the folds, you've got some, there's some more bacteria hidden in there. And, what if there was an infection, right? So then there's bacteria intracellularly, right? And the beauty of this is those bowel and the bowels that I was using for that particular slide, if I only use the small beads, we would never, ever, ever see the inside of those bowels at all, period. I mean, you would wash something out, right? Like you would wash some stool out and you would be able to homogenize that stool and you would lyse those bacteria and you would get that DNA out, but you would never get it inside that bowel. So by putting the big beads in there, you're able to grind up the bowel, and then the little beads can get in there. So then it's just this huge synergistic effect that you get lysis of the tissue. The tissue's in suspension along with the bacteria. The bacteria is now getting lysed. Now you have your analytes in suspension, and it just compounds after that. And that's what gives you that huge effect of the compounding and lysis. Now the next question, I know the last question was enrichment. Let me do the enrichment question first.
Yeah.
As far as enrichment goes, it depends, right? If you are working on an assay today that requires enrichment, it would likely work with that one as well. It may help you get better results if you implement bead beating earlier, or even at the end, you may get an increase in yield, right? Which will help you push that lysis step even sooner. I would argue that there may be a scenario where you don't need to enrich because we can get such good lysis. A lot of your enriching protocols will have you enrich for a few hours, and then post enrichment, you're going to do a chemical lysis, right? Well, unless you're lysing with that chemical for a day, you will not lyse everything, period. Going back to the slides, I don't have them pulled up for me, but if we went back to the slides, you would see there was an enzymatic digest. That enzymatic digest was an overnight digest, and we still got more pound for pound nucleic acid at the end of the day. So what that can tell us is that we're not lysing everything. There's still cells that still contain a large amount of our nucleic acid held back behind, right? So if we could get a better lysis and a better recovery, you may be able to actually get rid of the enrichment step. But obviously you'd have to develop that, right? Like that's pie in the sky. Like I totally understand that, right? As it stands today, the easy answer would be, yeah, you probably need to enrich to do some of your current steps. But you may very well be able to develop some cutting edge, fast food safety testing out of this using bead media to give you the best results.
Okay.
Second question was something. Yeah.
The second question is, what is the amount of sample needed for this bead extraction? It's more in the amount of sample.
So this is my go-to. I've been doing this for 5 years with Omni, and one of the craziest small samples I ever got was a single mosquito leg. They wanted to, this customer was trying to do some kind of vector-borne surveillance, and they asked, and it was very strange, could we homogenize a single mosquito leg in a tube? And like, I had no way to validate that, right? Besides using qPCR to see if the DNA result showed up downstream, right? You couldn't nano drop this stuff. There was the typical DNA analysis methods didn't work for like the quick method. So I went and blasted some primers, ordered some primers, brought them in, did a little science, and I showed verily we can get extract from a single mosquito leg. So with that being said, what is the sample size we need? It depends. So if you have an assay that you can run with X amount of DNA, and you reliably can recover that with our beading instrument on the front end, because we get very repeatable results and very good yields out of that, then you can make small assays, right? Make small target volumes, small sample inputs. I mean, the world's really your oyster when it comes to samples. I know that's kind of a cop-out. I'm not giving you a real number, but we can do all sorts of sizes. That's the beauty of the instrument, is that it can do everything from bone for bacteria, and then everything from small to large sample sizes. I mean, the instrument can truly process anything.
Okay, thank you so much for that. Next question is still anonymous. I think our participants are very shy. Among the many bead raptor equipment in the market, what are the characteristics or specifications we should look at for when it comes to samples, like which are meat, example like poultry, beef, seafood?
When it comes to those, I would say volumes are always a question, right? Volumes and throughput. Depending on your lab, the throughput is always a huge issue. Typically, bead mills, to do those samples, especially poultry and seafood, you're going to need to be able to do a high amount of force in that tube. Our Elite puts the most force out on the market. We put out enough force we can blow up tubes all the time. Like, that's not we sometimes it feels like too much force, right? And there's other bead beaters out there that it's more like a very, very gentle vortex, things like that, or a very vigorous vortex, I should say. But for tougher food samples, you're going to need very tough bead mills at the end of the day. That's what I would look for: large sample sizes and fast bead mills. Like that's the name of the game. It's just how quickly can you get these done, and how much force can you impart in that sample.
Just a follow-up question for that one. Will the oil content or the complexity, for example, how heterogeneous the sample is, will it really matter on our bead beating?
It can. Some of the oily samples, cannabis is a good example. The oilier it gets, they clump up. The samples will clump up around, and it's a little harder to recover it. Sometimes they stick to the sides or stick to the caps or the bottoms. They get in tight places of the tubes that they're processing in, and sometimes that matters. Usually what I recommend in that scenario is a solvent. For the most part, a solvent sort of takes care of everything there. That's usually where I start and stop, is always some kind of liquid needs to be the processing buffer. For oils, it's going to be an organic solvent. You're looking at, methanol, acetonitrile, something like that, as a solvent to keep that from going. But there's always workarounds, right? It just depends on if it's economic sometimes.
Thank you. Okay. Next question is, what is the minimum ratio of beads to sample for efficient lysis?
This is another "it depends" question. I hate giving these answers, but sometimes that's just what you're gonna get from me. Number of beads is always going to be a very varied question. So, for example, if you had a single large bead, like a big 25 millimeter, I mean, we're talking like a ball bearing, they're this big of a bead media. You put that inside of a tube, and it's the size of the tube. You're gonna process that sample, right? One bead. When it comes to the microbes, we can't even count those beads, right? We're measuring them by density, and you put a weight in there, and we have calculated how many beads are there, but we don't really know. And sometimes if you're working inside of a large tube, you're talking about millions of beads inside there. So it's very it depends question. The big takeaway there is, if you're working with solid samples and you're trying to get that sample homogenized and get those intracellular analytes out, and it's not bacterial, big beads are fine. The second that you introduce the bacteria question to those samples, that's when you need to start thinking about small bead media. Do I want to lyse that bacteria? If yes, there needs to be small bead media in here. That's just the simple start and go there. Otherwise, a few beads here and there, you get the job done.
Okay, thank you. How about the next question is, how about in the use of the beads? Will it actually, or will it have some risk when it comes to contaminations or introducing contamination to the sample itself, or to the nucleic acid that we are going to obtain from the experiment?
So some inferior quality beads can do that, right? Some people, you can get beads that have contaminants already on them. That's one of the things we pride ourselves in at Omni. We go through the effort of making sure our beads are clean. That's one starting point, right? If you're buying beads that are contaminated, don't be shocked, right? That's the downstream result could be it is coming from your reagents, right? And reputable vendors provide reputable products. That's always, just the long and short of that question. As far as using normal beads with RNA and DNA and protein, if you get good quality beads, they're not going to come with nucleases. They're not going to come with proteases. They're going to be clean. They're not going to leach anything. You can have a lot of assurance, especially with ceramic bead media and glass bead media, that there's nothing going to happen as far as reactions inside of that tube. If you have like a metal bead and you pump Trizol on top of there, your metal beads will rust, right? That won't happen with ceramic bead media. And so, picking good inert beads from reputable vendors is the first step in having good, starting point downstream extractions.
Thank you. Next question, still anonymous. Is bead beating only used to extract samples for bacterial analysis? Can it also be used for viral analysis?
Absolutely, all of the above. We use it typically. The normal, like 80% of bead beating is done in tissues for DNA and RNA extraction from tissues from just that tissue, right? A lot of research labs are doing research on mice. We can lyse up those mice organs very easily. There's tens of thousands. I pulled up references for bead beating on Google Scholar, and there's tens of thousands of references, and most of them are for mice, right? The bacteria bead beating, typically the references you'll see are for soil, fecal matter.
Mm-hmm.
Cultured bacteria is not as much there, but definitely it is something the bead mill can do. I would say if you have a solid sample of any kind, that introducing a bead mill on the front end will help you lyse anything. I mean, if you have bacteria, if you have regular old eukaryotic cells there, viral, fungal, anything, there's a bead to break open the cell membrane, the cell wall, the viral coat, whatever you need broken open, there's a bead for it.
The same principle.
Yes.
Yes. Thank you so much for that. Next question is, do you have data on, or if there is a huge effect on DNA integrity in case we have overdone bead beating? Example, instead of doing it just for 1 to 5 minutes, accidentally we left it for 10 to 20 minutes.
Your tube's going to boil. That's what's going to happen. I can tell you that from experience. So the good news is most bead mills, I know ours do, maybe not everybody's, but ours have time procedures. I mean, you will dial that time in before you start. But let's say you've got a sleepy grad student at the wheel and they're just running multiple protocols there, and it is what it is. there is shear that takes place, right? There'll be DNA shear, there'll be RNA shear. You know, in the case of RNA, that'll be really bad to start shearing that up over time. The good news is that for the vast majority of times, this is not an issue for our normal protocols. If you go back to that lysis slide where I did the cultured bacteria, the longest runs we did there were 3 minutes, and we had, you know, over 90% lysis. You combine that with some enzymatic lysis, you combine that with some chemical lysis, and you'll get 100% in 3 minutes. So, you know, we've seen shear, but even from the high molecular weight, you're still looking at several thousand base pair strands here. I mean, tens of thousand base pair strands. So the molecular weight's still very high and very good for sequencing, and even including, you know, whole genome sequencing. We've seen results for that. So I would say that there is data to show what happens the longer you go. And then you're always going to be kind of fighting those two trends of shear versus lysis and things like that. But as far as degradation goes, a lot of that's driven by heat. And you can control that, right? With coolers, with cold buffers, with dwells in your life. There's always a lot of workarounds. And I always like to point to the fact that you know, ours are totally programmable, and you can set it once and forget it, and your lab will always have the protocol saved. So that helps.
Thank you. Okay, so we will be entertaining last 3 questions from our audience. So we would like to thank our audience for actively participating by keying in your questions. Okay, the third to the last question is still anonymous. Can high microbial load food samples affect the lysis and recovery of the target genetic material? Why or why not? I think, let me just add to that. It will be very beneficial because many of foods here in the Philippines are street foods, and there's a high risk to contamination. So
Gotcha.
especially for high microbial loads. So will it actually have an effect on the lysis, and how will it also affect on the recovery of the target genetic material?
Gotcha. So interestingly enough, I didn't put this in the slide, but we've approached this from both ways. So on one test, we approached it bottom up, where we tested a low spike, right? So we still have to be able to count them. So like in food, 100 is really not a low spike, right? 100 CFU is a pretty high spike for anything, but I have to be able to count them, right? So I did 100 CFUs on the low end of our spike. And on the back end, I did 1,000,000 CFU spike, which then I diluted down to 100 to count, right? So on both of them, we saw the exact same results, right? At the end of the day, we're getting around that same 10% or less lysis, no matter what, whether it's a small CFU spike or a large CFU spike. And that's just all driven by the beads themselves, right? They're non-discriminate. They're just passing through the sample, and it's just a matter of time before they lyse everything that's there. Again, it's these organisms, if you think about in size, you know, even a 0.1 millimeter bead is still hundreds of times bigger than a bacterium, right? I mean, you're talking like, it's not that contact. It is the act of actually running it through that liquid that's doing the work, and it's a function of time.
Okay, thank you. Next, second to the last question is still anonymous. How economical are our beads? Like after single use, how are beads cleaned, and how reusable are these beads before needing replacement?
So the beads are reusable, right? Like you could wash them, you could clean them, you could take all the time in the world and all the validation that you need to do to clean them. At the end of the day, they're very robust beads, so they can be used more than once. I don't like to recommend it because so often in a microbial lab, you're fighting against one, microbial contamination, two, you're fighting against analyte contamination, much less if you're going downstream and something like amplicon contamination, right? You've got all these different contaminants to worry about, and then you go and start reusing a bead tube, right? So it can be done. I don't like to recommend it, but they are reusable, right? At the end of the day, if you need to reuse these things, you could clean them but you absolutely need to validate that cleaning procedure. And it's going to be, it is a lot of effort on the user's end to actually have to filter everything out, clean, sterilize, validate all that. So it can be done, long story short.
Okay, thank you. And our last question. So before I read the last questions, for our participants, you can still key in your questions. If we will not be able to entertain it during this Q&A session, so just continue keying in because we will just forward it to our speaker for him to answer at a later time. Thank you so much for all of your questions and for your interest in our webinar. Okay, the last, but definitely not the least question is, are the shred I don't know if I have read it correctly, shred DNA fragments from beet beating contaminate the sample?
Could you repeat that?
Are the shred, or let me just spell
Sheared?
it. Yeah, that's one. Sorry.
Okay.
DNA fragments from the beet beating contaminate the sample.
No, because the shear would affect the DNA from the sample itself, right? There's no DNA coming with the beads to the sample. So whatever DNA you have there that we're shearing is just going to be present in the sample itself. It's just going to be a product of the actual bead beating process itself, right? So you've got this genomic DNA that's sitting there, and it's, you know, millions of base pairs, and the process itself is going to start shearing that down to some degree. It's not, I wouldn't consider it contamination unless you have an assay that's incredibly sensitive to shear. And at the end of the day, you can work around that, right? There's various assays out there. I know that work with whole genome that worry about shear. And for the most part, we dial that assay in time and bead wise to minimize the shear effects.
Thank you so much. Just one additional, just
fine.
one additional to entertain. Does bead quantity matter in terms of the number of yield?
It does, and this is a very tricky answer. So the beads themselves, one thing you have to think about is they take up space in the tube. So you have a 2 ml tube, and in that tube, currently we take up 1/10 or so of that space. The more beads you pack in there, the more shear you have. 2, the quicker the processing run goes. So that's a good thing, right? But 3, you don't recover as much sample because you can't pipette it out of the beads, right? And you have less volume to work with the beads. But something like those 0.1 beads are like sand. If you've ever been to the beach, you get a bucket of sand, you can pour a lot of water in that sand, right? Yeah. So you lose a lot of that sample. And at the end of the day, the total recovery of target intracellular analyte is often driven better by less beads. It may seem counterintuitive, but just run your process longer to get the lysis you're looking for so that you can recover the most amount of sample. It's something that you want to dial in. We spend a lot of time in our lab focusing on the customer's needs for that, and as well as making sure that the downstream itself is done. So that's one of the benefits of having pre-filled tubes. But if it's something you're trying to dial in yourself, you have to think about that as how much of this sample am I trying to get out of here, and at the end of the day, is this actually going to be beneficial to have a ton of beads that I'm getting quicker runs done, but you're not recovering your samples. So just something to think about.
Thank you so much, Sir Caleb, for all of your responses from the questions of our participants. And to all of our participants, thank you. Maraming salamat po for all of your questions, which actually have provided additional info, additional learnings from the talk of our webinar for this morning, understanding the impact of bead beating in sample preparation of food for microbial analysis. Once again, maraming salamat po to all of us. Okay? And at this juncture, let me present this certificate of appreciation to Mr. Caleb Proctor for his topic, understanding the impact of bead beating in sample preparation of food for microbial analysis, for sharing invaluable knowledge as a resource speaker in the DOST OneLab Webinar 2022, held on the 25th of August via video conferencing, live via Zoom and YouTube channel. Given this 25th of August 2022 at Bicutan, Taguig City, Republic of the Philippines. Signed by Dr. Annabel Briones, Director, Scientist 1 of DOST-ITDI, OneLab Co-Project Leader, and Ms. Rosemary Salazar, the Chief Admin Officer of DOST Region 9, OneLab Project Leader. Let's give Sir Caleb a virtual round of applause. Or kung saan man kayo dyan sa YouTube channel po natin nanonood, let's give him our palakpakan. Thank you so much.
Thank you so much. I appreciate that.
Thank you so much.
It's been an honor. This is the first one of these kind of talks I've ever done, and it's been a joy. I really appreciate it.
Thank you so much. So, in this awarding of certificate of appreciation, I would like to request Ma'am Rose to open her camera so that we can have a photo opportunity. And also, may I also request Ma'am Christine as a representative of the Food and Nutrition Research Institute. Okay, let me there. Okay, so now we can have our group photo. So please give us your best smiles, ladies and gentlemen. 1, 2, smile. One more. Okay, thank you so much. Sir Caleb, once again, thank you so much for this opportunity to have this webinar.
I appreciate it.
Mr.
Thank you.
Caleb. Thank you very much from OneLab.
Thank you for having me out here tonight or this morning. Whatever.
Thank you so much, Ma'am Rose, and thank you so much, Sir Caleb. We know that it's already around almost 10:30 in the evening in the US, but you're still with us, providing us with insights about your topic. Okay, so at the next part is the online attendance form is already open. So for all of our participants who joined us in our webinar, the link which we sent to your email address and also posted at the YouTube channel of DOST-ITDI for this live streaming is now already open. So you may access the link to this online attendance and evaluation form in order for you to be provided a copy of your e-certificate of webinar participation. This is also a reminder for all of our registered chemists, chemical technicians, medical technologists, and chemical engineers to please make sure that you key in or record your attendance and give us your feedback on how we can improve our logistics and the way we conducted or our way we will be conducting future webinars of DOST OneLab. For the mentioned professions, these are your attendance recording and evaluation are both needed for us to provide you with the CPD units. As mentioned earlier in the earlier part of our program, these professions are provided 2 CPD units each. Okay, so you may access the link provided here or you may scan now the QR code. Okay, so with that, this has been Admiral Ray CW, your webinar MC. Thank you so much for your attendance to our webinar. And we hope to see you in our future webinar activities of the DOST OneLab. Maraming salamat po sa ating lahat and ingat po, stay safe, healthy, and happy. Good day, everyone. Thank you.
Built upon the innovative design and unsurpassed quality of Omni's BeadRaptor family, the BeadRaptor 4 provides powerful performance in an extremely compact design. The BeadRaptor 4 is designed with a small footprint to maximize bench space. For ease of use, the BeadRaptor 4 has an integrated front-loading snap-in tube holder. Homogenize in volumes ranging from 500 microliters to 7 milliliters using the BeadRaptor 4. The powerful motor allows processing up to 5 meters per second and is ideal for soft tissue and cells. The BeadRaptor 4 is equipped with variable speed and time control to accommodate multiple sample types. The OmniTH tissue homogenizer is ideal for small-scale analytical laboratories. The TH features a powerful, compact 150-watt motor with variable speed control and separate on-off switch. The lightweight and ergonomic design make the TH a perfect fit for handheld operation. A specially designed stand clamp is also provided with the TH, enabling it to be post-mounted to a lab stand when applications require extended processing. A wide array of Omni generator probes are available. Choose from flat bottom for soft tissues and emulsions, or sawtooth configurations for tougher tissue samples. Omni generator probes feature quick connect couplings to ensure rapid probe exchange. The Omni PCR kit with disposable generator probes is ideal for PCR and extracting nucleic acids. OmniTip generator probes are disposable and completely eliminate the risk of cross-contamination. The Omni GLH 850 offers the ultimate performance with a powerful 850-watt motor and digital speed controls ranging from 5,000 to 25,000 RPM. It is capable of processing at smaller lab scale quantities or at larger production scale quantities up to 10 liters in volume. The GLH 850's robust processing ensures complete homogeneous and uniform particle size distributions. The integrated motor feedback holds set speeds during homogenization to ensure repeatable results regardless of any fluctuations in sample viscosity. The Omni GLH 850 features a timer that can be set from 1 second to 10 minutes and also features a delayed motor start time for applications requiring a fume hood during homogenization. The Omni GLH 850 is compatible with the widest range of generator probes from 5mm to 30mm in diameter. It is able to create fine emulsions by using the flat-bottom generator probes or process tougher samples by using the sawtooth generator probes.
Having your samples tested can be such a hassle. Moving from one laboratory to another to complete the necessary testing and calibration requirements, with a lack of standardized pricing for tests and calibrations and little assurance for high-quality service. There is always a way to have a convenient laboratory testing and calibration experience. The Department of Science and Technology presents OneLab. OneLab is an IT-based one-stop laboratory platform that allows you to access integrated government and private laboratories across the region. OneLab is a network of government and private laboratories through the region through an IT-based referral system, linking them to provide convenient access to the public and allowing samples to be referred to other laboratories in other regions. To ensure that the customer's testing and calibration needs are met, OneLab handles receiving, referral, transport, analysis, and delivery of results through an IT-based referral system For efficient laboratory transaction management, OneLab harmonizes and integrates laboratory test and calibration services, thus eliminating the need of the customers to shuttle from one laboratory to another to complete their laboratory testing and calibration requirements. With an extensive list of services, OneLab guarantees the accessibility and availability of consistent quality service, promises user-friendly instructions on testing and calibration requirements and pricing. So, how does it work? Customers through OneLab can have all of their laboratory testing and calibration needs in a single touchpoint. OneLab also allows customers to have an idea on the pricing for the desired tests and/or calibration. As soon as the customer hands in the samples to the nearest OneLab member laboratory, OneLab takes everything from there. The lab receives the samples and refers it to the laboratory that can provide the required service. OneLab gives its customers an access to track the status of their test requests through the customer portal, which will also be available in Android with the needed information being available at their fingertips. Customers just need to wait until the results are available, which can be received through email, fax, or pickup. Customers are assured of accurate and complete instructions regarding their testing requirements. How is this possible? With OneLab, customers from the industry, business sector, and the academe can have a more convenient laboratory testing and calibrations. No more expensive, tiresome, and time-consuming travel from one lab to another to complete testing needs. Through OneLab, customers are assured of high quality and efficient services through ISO IEC 17025 accredited internationally recognized member laboratories. OneLab is committed to providing timely, convenient, and readily accessible services to sustain high satisfaction rating from customers. One laboratory worldwide. This is OneLab.